right, welcome back. Let's take a look at how to write names and formulas for these ionic compounds that include polyatomic ions. Now, the procedure is just the same as for any other ion. Naming them, we name the two ions. You have to remember them because they all have their own individual names. And writing the formulas, we figure out how many of each ion we have, and then we write the ion without the charge with a subscript telling how many. Couple of pitfalls people get into: don't mix up the subscript in the charge. So for example, ammonium, NH4, that 4 means there are 4 hydrogens in the ion. The charge, this little plus, is by itself, so it's 1 plus or plus 1. Carbonate, CO3, means it's got 1 carbon and 3 oxygens. 2 minus is the charge. So when we write the ion, we're going to write the carbon, the oxygen, and the 3s, showing there are 3 oxygens. We're not going to write the charge. Don't forget that these little numbers are part of that cluster. That's carbonate, for example, is a cluster of 1 carbon and 3 oxygens. They always stay together. They always have a charge of -2. We don't write the -2 in the compound, but you don't want to lose this little 3 because we're trying to represent 1 carbon and 3 oxygens. All right, let's look at some problems of the sort that are on your worksheet. So the first few, I gave you the ions. So here we have sodium, which is +1, and carbonate, which is -2. So for finding the formula, the big thing is figuring out how many we need of each one. So a +1 and a -2. -2 is a lot more charge. We need more charge from the +1. If we had 2 of these, then the formula would have 2 +1s or +2, and it would have -2, and the positive and negative charges would be the same. So we must have to have 2 sodiums and 1 carbonate. So we're going to see if we can get over here to where it says formula, and we're going to do Na, little subscript 2, and then CO, and we have to copy the entire formula for carbonate, CO3. Okay, I can't remember if I inadvertently said the name of it, but the name is just the names of the 2 ions. So the first ion is sodium, and the second ion is carbonate. If we look back up, carbonate. So we're just going to name the 2 ions. Sodium ion, carbonate ion. Oops. All right, let's take a look at the next one. And just for fun, let's get some color other than pouring black. All right, so we have, oh, I goofed here. I didn't give you the charge on. All right, we have lead 4 plus and nitrate -1. So I hope you can see that it's going to take 4 nitrates to balance 1 lead. So we'll put 1 under the lead, and it's going to take 4 of these. So how are we going to write this formula? 1 lead, Pb. Now, if we have more than 1 of a polyatomic ion, we're going to put parentheses around it. Look, we have NO3. And we want to have 4 of those things. Well, we want to make sure that it's clear that there's 4 of the whole ion. 4 nitrates, not 4 oxygens, 4 nitrates. So what we're going to do is to show that the 4 applies to the entire polyatomic ion. I don't know why I'm having trouble with that. We're going to put parentheses around the polyatomic ion, and then we put in the 4. And I was going to try to do pretty colors, but I didn't manage to do that. So let's do it now. PbNO3, 4. 1 lead ion, 4 nitrate ions. Now, I've been calling this a lead ion, but you might remember that lead and tin, even though they're not in the transition metals, are 2 metals that can form more than 1 ion. Therefore, we need to have a Roman numeral with it. So what is the Roman numeral here? Well, we need to figure out what the total charge is. Nitrate has a charge of -1. There are 4 of them. The negative charge has to be -4. So the positive charge has to be +4. There is only one lead ion. That's got to supply all 4 by itself. So that means that lead is +4, and the Roman numeral we write for it is going to be Roman numeral 4. Lead 4, and the anion is nitrate. All right, next one gave you the formula. So you need to figure out the ions. So you can figure out the ion. Come on, back up one. All right, let's make it pretty green. Let's make another color. Let's make it dark gold. If you look at your periodic table, you can very quickly see that calcium is in group 2, and it forms a +2 ion. So you can fill in the ions here by going Ca2+. And that other ion, if you hopefully memorize it, OH, has a charge of -1, is hydroxide. OH, you might have to look it up. I hope you memorize the charge, but it's OH minus. All right, let's move that back over. All right, there are 2 of them because it's -1. 2 -1s balances out the +2. All right, over to here. Let's get that nice gold again. So the ion, the first ion, the cation, the metal is calcium. And the ion, and if you don't remember it, if you haven't memorized them, you can look them up in your ion table. OH minus is hydroxide. All right, let's try another one. All right, we have Cr, you can find in the periodic table, in the transition metals, I mean. And actually it does make, I think, some purple solutions, so we'll do it in purple. And because it's a transition metal, we're not really sure what the charge is until we figure it out. So we'll write Cr, and because it's a metal, it's a cation, it's got to be something plus. And our negative ion, PO4, and if you look that up, jumping ahead, the name is phosphate and the charge is 3-. All right, so if we have 3- and we have parentheses showing we have 2 phosphates here, that's a total negative charge of -6, right? -3 from 1 phosphate times 2 phosphates, -6. So the total positive charge must be +6. +6 is divided up among how many chromiums? 3. +6 divided by 3, that's +2 per chromium. So we can go back in here and put in our +2. All right, let's see if we can find that pretty purple color again. So I think I mentioned the name phosphate, and the metal is chromium, and we figured out that caps lock, chromium, and we figured out that it's +2, so it gets a Roman numeral 2, and phosphate. I'm just gonna let that, well, no, I'll hit it with a backward tab. There we go. And I think I've got a couple more. Okay, somewhere I gave you the name. So if you're given the name, let's start by trying to find the ions, and then we'll use the charges, put them together, and get the formula. So potassium, by this time, you're probably pretty comfortable finding that one. We'll make that a dark red. Potassium is in group 1. That's K plus. Plus, there we go. And sulfate, you might have to look in your list of polyatomic ions. That's SO4. 2 minus. And we'll hit that with a couple back tabs. All right, so we have a +1, +1, and we have a -2. Obviously, we need more positive charge. 2 plus 1s will be +2. That will balance the -2. So our formula is going to have 2 of these and 1 of those. So it's going to be K2SO4. So that 4 from the formula stays in there. 4. But the charge disappears. Okay, that's a big difference. You got lots of little numbers in here, but the charge is not written in the formula for the compound. The 4, the subscript, is very important because that tells you there are 4 oxygens in that cluster. All right, one more. Don't think this one's going to need parentheses. So let's figure out what we have here. Copper 1 sulfide. All right, copper 1 is going to be Cu, let's make it green. Cu with a plus. And sulfide, what is sulfide? Is it a polyatomic ion? You got to watch out for those endings. This is sulfate. Ide always means one of those ions that is made from a single atom anion that you can find on the periodic table. So sulfide is the ion made from sulfur. If you look at the periodic table, you'll find that that's in the column with oxygen. Everything in that column has a charge of -2. So we have S, 2 minus. All right. Little back up there. +1, 2 minus. We're going to need another copper. 2 plus 1s is +2, and 1, 2 minus is -2. So we're going to have Cu2SO4. 4 sulfates. It's the 4 that was part of the formula to start with. So I hope this is enough of an illustration to show you how you can just go ahead, just the way you've been doing with the names and the formulas. You're going to take the ion, you're going to use the charge. The only trick is that you need to write the complete ion, and you need to know that the little subscript is part of the formula of the ion. That's got to be written with the ion, does not come off, and that only the little number up top is the charge. And a particular mistake people make is they look at nitrate, and it's got this little minus sitting here all by itself, and they somehow think that that 3 is part of the charge. Nitrate is -1. It has 3 oxygens in it. Acetate is -1. Hydroxide is -1. Those guys aren't as confusing. Well, this one, I guess you could mix it up with the 2. The charge is what you use to figure out the formula, but it does not get written in the final compound. I hope that is enough for you to go ahead and complete the worksheet. Have any problems, email me. I'm going to work on getting this remind together so you can also text me for help. Take care.